Hi everyone, this lesson is going to be demonstrating how we solve some of these logarithmic type equations. So let's begin. We have 1/2 multiplied by log of 16. This is a common log using base 10 plus 2 times log of 5 base 10. Now we'll use the power rule. So this is the same as 16 to the power half, and this one is the same as log of 5 squared. Remember, the number at the front can become the power inside the logarithm. So a power of a half, 16 to the power half, is the same as square root 16. And that's the same as 5 times 5, or 25. So we have the log of 4. Square root 16 is 4. Still the log of 25. And now, because we're adding logarithms with the same base, we can combine these with multiplication. So we have the log to base 10 of 100, expressing 100 as 10 squared. We can see that using the power rule in reverse, that would be 2 multiplied by the log of 10 to base 10. Now, as we know, the log of any number with using itself as a base is 1. That's really just 2 times 1. And so our answer to that one is 2. Let's do part B. Beg your pardon, it's part C. So I have log base 2 of 128 plus, looks like that's going to have to move over a bit. Okay, back to where we were, plus log base 3 of 45 minus log base 3 of 5. So first of all, I want to change 128 into a power of 2. So that one's not really obvious. Let's divide by 2 and we're left with 64. I'm doing a prime decomposition. So 2 goes into that 32 times, 2 goes into that 16 times, 2 into that 8 times, nearly there, 2 into that 4 times, and then 2 into that twice. So it seems like 1, 2, 3, 4, 7 powers of 2. So this is the same as 2 to the 7th power. Now here I have 2 logarithms to base 3. And when subtracting, we can make this a division, 45 divided by 5. As we saw earlier, if it is a power of 7, it can come to the front, and then log of 2 base 2 is just times by 1. And this is the log base 3 of 9. 45 over 5 is 9. Now I'll express 9 as 2, my mistake, that should have been 3 squared. So that's 7 plus 2, and the solution is 9. That's that one. Move this little bit of rough working we had there. And we'll move this across a bit and we'll do part E. Okay, part E. We have log to base B of B cubed minus log to base B of the square root of B. So using subtraction, this is B cubed divided by the square root of B, all with the same log now. Must only do this if the logs have the same base. So that's B cubed over, and I'll write this as B to the power 1/2 instead of square root B. Now, with indices, when I divide things with the same base, I subtract their indices. 3 take away 1/2 is 2.5. And now we're seeing this one before. The answer is just the index there, 2.5. Part G, here we go. x times the log base 2 of 8 plus log base 2 of 8 to the power 1 minus x. Okay, this is interesting. We could do this one in a few different ways, but let's start by using that multiplication of x and turning it into a power. And the second logarithm hasn't changed. It's 8 to the power 1 minus x. Now I have two logarithms added together with the same base. So I can write 8 to the power of x multiplied by 8 to the power of 1 minus x. So when multiplying things that have the same base, I add the exponents together. Now we should see here that x subtract x disappears. This is really 8 to the power of 1. 8 to the power of 1 is 8, which I will express as 2 cubed. So the answer to this one is 3. All right, that's 4 quick logarithm equations. Thanks for watching.